Hi students, in this video we are going to discuss about probability and statistics. Unit 4, design of experiments, and the topic is Latin square method. Latin square method is one of the three-way classification. Already we are familiar with the one-way classification and two-way classification. In one-way classification we have analyzed the data by column wise only, and two-way classification we have analyzed the data by column wise and row wise. Here we have added one more word, treatment or letter. Example, variety of seeds, types of spacing or plots, different maneuver treatment. So in the way of defining the null hypothesis, there is no significant difference between rows, between columns, between treatments. And alternative hypothesis H1, there is significant difference between rows, between columns, between treatments. See the ANOVA table of three-way classification. See, source of variation we are taking by between columns, between rows, between letters or between treatments, residual or error. First column, sum of squares. So how do we read this one? Sum of squares of columns, SSC. Sum of squares of rows, SSR. Sum of squares of letters or sum of squares of treatment, SSK. Sum of squares of error, SSE. And degrees of freedom, n minus 1, n minus 1, n minus 1 for all column row treatment, and for error n minus 1 into n minus 2. Next column, mean square, that is short form MS. So how do we denote this one? Mean square of columns, mean square of rows, mean square of letters or mean square of treatment, mean square of errors. So what is the formula? Mean square of columns, SSC divided by n minus 1. Mean square of rows, SSR divided by n minus 1. So first divided by second. For MSK, mean square of treatment, SSK divided by n minus 1, first divided by second. The same way MSE, first divided by second. Okay. So variation ratio for column, MSC divided by MSE. And variation ratio for rows, MSR divided by MSE. Variation ratio for treatment, MSK divided by MSE. Now let me tell you one thing, it is not true for always. Why? FC, FR, FK should be calculated in such a way that FC, FR, FK should be greater than 1. So if it is greater than 1, we choose if MSE less than MSE, keep it MSE numerator. Okay. In the same way here also, if MSR less than MSE, we keep MSE in numerator. So which one is compare these two value, which one is greater value, that come to numerator. So capital N, total number of observation. Capital T, total value of all the observations. Now the correction factors is a formula T square divided by N. Already we have seen what is T and what is capital N. And total sum of squares, summation xi square minus t square divided by n, that is correction factor. The same way we have the formula sum of squares of column, sum of squares of rows, sum of squares of treatment, sum of squares of errors. Sum of squares of errors is nothing but TSS minus SSC minus SSR minus SSK. And find the table value of F for degrees of freedom. V1 equal to C minus 1, column minus 1. V2 equal to number of rows minus 1, or numerator and denominator. Okay. At the alpha percentage level of significance, if alpha value is given, we take that value. Otherwise, we take this common 0.05, that is 5%. So what is the conclusion? If F value, calculated value less than the tabulated value, we can accept H0. Otherwise, we reject the H0. Let us see one problem. A variable trial was conducted on wheat with 4 varieties in a Latin square design. The plan of the experiment and per plot yield are given below. See the table, analyze data and interpret the result. Sometimes they have said we have analyze the data by column wise and row wise and treatment wise, or by seed wise or fertilizer wise or something etc. Okay, so from the way we identify the problem given in Latin square method, but here it is given directly Latin square design, so we can analyze the data by three-way classification. So first we define the null hypothesis. There is no significant difference between columns, between treatments and between rows, and alternative hypothesis, there is significant difference between rows, between columns, between treatment. Here no is there. Actually, what is the statement? There is a significant difference between rows, columns and treatments. First, we shall subtract 20 from each value. Okay, so see the value. We are having square values only now. So avoid the two-digit number, make it single-digit number by subtracting one common value 20. I choose this number. I found 20 may be the common value for all the numbers, so I choose 20. So subtract 25 minus 20, 23 minus 20, 20 minus 20, like that up to 15 minus 20. So what is the answer? 5, 3, 0, 0, minus 1, minus 1, 1, minus 2, minus 1, minus 6, minus 3, 0, minus 3, 0, 1, minus 5. Okay. Now, see, this value becomes the single digit value like this by subtracting 20. Okay. Now, total of this value 5 plus 3, 8, minus 1, minus 1, plus 1, minus 2, minus 3. Okay. So, minus 1, minus 6, minus 7, minus 10, minus 10, minus 3 plus 1, minus 2, minus 2, minus 5, minus 7, and add by column wise minus 1, minus 1, minus 2, minus 3, minus 5, minus 5 plus 5, 0. Like that, sum of these values minus 4, sum of this value minus 1, sum of these values minus 7. Now, squares values 5 square value 25, 3 square value 9, 0, 0 square only, minus 1 square value 1, 1, 1 square value 1, minus 2 square value 4. Like that, minus 1, 1, minus 6 square 36, minus 3 square 9, 0 square 0, and minus 3 square 9, 0 square 0, 1 square 1, minus 5 square value 25. Okay, and these are the total values. Sum of the total 25 plus 1 plus 1 9, 36, 10 46, 10 11, and 4 plus 25 29. Okay, these are the table values. Now, from the take this table value for reference, now we have to find out some following important values. Capital N, the total number of frequencies, 4 number of columns, 4 number of rows. So 4 into 4, 16, and capital T equal to the total value equal to minus 12, and the correlation factor T square divided by N. So minus 12 square now 144, and divided by 16 value equal to 9. So total sum of squares. So where is the sum of squares? These are the squares value 36, 46, 11. Add all the values up to 29 minus the correlation factor, correction factor minus 9 equal to 113. Now sum of squares of columns. Sum of squares of columns. Now these are the columns. See, sum of the column 0, 0 square, minus 4 square, minus 1 square, minus 7 square, minus the correction factor 9. What is the answer? 7.5. And the sum of squares of rows. These are the rows values. What are the sum of rows? See, if you are having the original value, it comes some 3-digit number. After subtracting 20, it comes a very simple number. Manually, we can calculate all these things. For that purpose only, we are subtracting 20. See the row value 8, minus 3, minus 10, minus 7. What are the square values? 8 square, minus 3 square, minus 10 square, and minus 7 square. Okay, divided by 1 by n minus the correction factor 9. What is the answer? 46.5. Especially below above the two values are enough for SSC and SSR for two-way classification. Now this is Latin square only now. That is three-way classification. We need one more term, treatment. See, take the as usual table value. This is given 1. So Let us arrange the table value in order to A, B, C, D separately. Okay, well, if it is A seeds or any plants or any weeds or like etc. Okay, so I have to arrange A like this. From A, first row 20, second row 19, third row 14, fourth row 15. A value is over. Now B value, first 23, second 18, third 19, fourth 21. Arranged like this. And C value, first row 25, second row 21, and third row 20, and fourth row 20. The small mistake here, 25. Okay, and D value 20, D value 19, D value 17, and D value 17. Here also we subtract 20 from each values. 20 minus 20, 0. 23 minus 20, 3. Here not 21, here 25. 25 minus 20, 5. 20 minus 20, 0. Like that, 19 minus 20, minus 1. 18 minus 20, minus 2. 25 minus 20, here 5 will come, and 19 minus 20, minus 1, and 14 minus 20, minus 6. 19 minus 20, minus 1. Like that, we have found all the values by subtracting 20. Minus 12, 1, 6, and minus 7. Now let us come to the way of finding SSK. Okay, so what are the sum? Minus 12, 1, 6, minus 7, the separate squares, minus the correction factor 9. What is the answer? 48.5. And now we come to SSE. So SSE we found by TSS minus SSE minus SSR minus SSK. So total sum of squares of column, sum of squares of rows, and sum of squares of treatment. So we have the data here. Substitute here, you may get the answer 10.5. Now the ANOVA table. Source of variation between columns, between rows, between letters or between treatments, and error. See the sum of squares value 7.5. Sum of squares of rows 46.5. Sum of squares of treatment 48.5. Sum of squares of error 10.5. Okay, here degrees of freedom. Here n value is common because the Latin square method both the column and row should be same. So n minus 1 equal to 3, 3, 3. And SSE n minus 1 into n minus 2. So 3 into 2 equal to 6. Now how do we find mean square of columns? This one divided by this one. So sum of squares divided by degrees of freedom. What is the answer? 2.5. And mean square of rows, SSR divided by degrees of freedom, 15.5. And MSK first divided by second, 16.17. For mean square of error, first divided by second, 1.75. Okay, so variation ratio. So how we are going to obtain the variation ratio? Already I told that FC, FR, FK should be greater than 1. Okay, so compare 2.5 with 1.75. 2.5 greater than 1.5. So numerator MSC divided by denominator MSC. What is the answer? 2.5 divided by 1.75. Use your calculator. You may get the answer 1.43. Okay, next FR 8.86 and 1.75. 15.5 divided by 1.75. What is the answer? 8.86. And variation ratio of treatment 16.17 greater than 1.75. So this one comes numerator, MSC comes denominator. What is the answer? 9.24. Okay, so here alpha value is not given, so we are taking 5%. So MSC. How do you obtain this 3 and 6? By numerator and denominator. Here numerator MSC degrees of freedom 3, and denominator MSC degrees of freedom 6. So 3, 6. Like that, MSR degrees of freedom 3, MSC degrees of freedom 6. So MSK numerator degrees of freedom 3, MSC degrees of freedom 6. So 3, 6 common for all the column, row, and treatment. Now how do we obtain the F table? See, numerator 3, denominator 6, where it is matched 4.754. So table value and calculated value. So between columns F calculated between columns 4.76, between columns 1.43, it is the tabulated value, and here 4.76. So FC less than 4.76. So we accept there is no significant difference between columns. Second, 8.86 greater than 4.76. So this value greater than the table value. So we can reject there is significant difference. There is no significant difference between rows because calculated value greater than table value, and 9.24 greater than 4.76. Here also we reject H0. So we can accept only H0 in between column only. So between rows, between treatment, H0 is rejected. Hence we conclude that there is a significant difference between rows and treatments. Thank you.